All right, so looking now to some examples. So first thing to do, right, is remember, permutation order matters, combination order does not matter. That's going to be one of the first things you have to do when you look at the quiz for this, in that you're going to determine, is this a fundamental counting principle problem, is it a permutation, or is it a combination? And it's all going to be based off the type of question and how it is asked. Thus, 8 students are applying for a committee of 3 people. In how many ways can the committee be chosen? So this is a committee, right? So we talked about that if they're being chosen for a committee, the order that they are chosen does not matter. So this is a combination problem. So we need to think about how many people are we choosing from and how many times are we choosing. Let's look back really quickly to this one. N is the number of items to choose from. N is the number of items to choose from. R is the number of times we are choosing. So, sorry about that. We are choosing from 3, and we are choosing, not from 3. We are choosing from 8 people. There we go. And we are choosing 3 times. So technically this is an 8C3 or an 8 choosing 3. Our formula, 8 factorial over 8 minus 3 factorial times 3 factorial. Let's simplify this a little bit. Now, I'm going to wait to multiply stuff out to a little bit here. So that becomes 8 factorial over 8 minus 3 is 5. So that's 5 factorial over 3 factorial. Now remember, when you have factorials, let's say I had 5 factorial over 3 factorial. The 3 factorial reduces out some of the numerator. So I have 5, 4, 3, 2, 1 in the top, and in the bottom I have 3, 2, 1. That means 3, 2, 1 in the bottom and the top goes away. So 5 factorial over 3 factorial is technically just 5 times 4. Now when we look in our problem below, that's 8, 7, 6, 5, 4, 3, 2, 1 over 5, 4, 3, 2, 1, 3, 2, 1. So technically it's 8, 7, 6, 5, 4, 3, 2, 1, 5, 4, 3, 2, 1. And then again, you have this 3 factorial still, so there's another 3, 2, 1. Now, all of this stuff is getting multiplied together. So because it's all getting multiplied together, we can reduce. Now, the easiest thing to do is going to be to reduce the largest factorial in the denominator. In that case, it would be this 5 factorial. So 5, 4, 3, 2, 1 is going to go away, which means in the numerator, 5, 4, 3, 2, 1 goes away as well. So all we're left with now is 8 times 7 times 6 divided by 3 times 2 times 1. And then for that, we can just use a calculator. So 8 times 7 times 6, that's 336. And then 3, 2, 1, that's 3 times, that's 6. So 336 divided by 6. There are 56 different ways a committee of 3 people can be chosen from a group of 8. So there's 56 different outcomes. Okay. Let's look at another one. Your PE teacher is picking 8 students from your class of 40 to go on a field trip. In how many ways can the students be chosen? So they're going on the field trip. If you get picked 8 first to go on the field trip, or if you get picked 7th, you're still going on the field trip. So order does not matter. So we have 40 students to choose from. We're choosing 8 times. So that would be a 40C8, which ends up being 40 factorial over 40 minus 8 factorial times 8 factorial. Simplify. 40 factorial over 40 minus 8 is 32. 32 factorial, 8 factorial. Now, you definitely don't want to write out all the numbers here. Like in the top problem, we did 8 to 1. That was pretty easy because there weren't that many. But you're not going to write out 40 factorial as 40, 39, 38, 37, 36. Okay, so the easiest way to do this is going to be whatever this number is, you just subtract this from that amount. Meaning 40 factorial over 32 factorial, 32 and whatever number all the way to 1 goes away from that 40 factorial. So that means when this goes away in the bottom, that 32 factorial, what you're left with up top is 40, 39, 38, 37, 36, 35, 34, 33. Seems like a lot, I know. Okay? And in the bottom, we have 8 factorial. Okay? So now, your calculator might struggle with this. But just kind of see if you can do it. So you're going to do 40 times all of that. So 40 times 39 times 38 times 37 times 36 times 35 times 34 times 33. It's a really big number. Okay, so like for example, my calculator can't even handle that. So like when I do 40 times 39 times all like this top part in my calculator, this is what I get. I get 3.10079 to the e to the 12th. What that means is that's scientific notation. Okay? But if I just leave that and I just divide that amount by 8 factorial, okay, then I get 76904,685. So there's 76,904,685 different ways that teacher can pick 8 different students to go on the field trip if there are 40 students to pick from, which is a crazy amount. Okay? Now, again, guys, I'll try to link a video of ways to do this. If you have one of the simple scientific calculators that I told you to get for trig, there's a probability button. It's kind of in the middle, I believe. If you press that, that's where you can find like a factorial button, and it even has NPR and NCR. Okay, so again, I'll try to find a YouTube video to link on how to do that. And I'll try to not have your numbers be as big. So let's do a couple more examples, and then we'll be done. Next problem. So it says a standard deck of cards contains 13 clubs, 13 spades, 13 diamonds, and 13 hearts. Clubs and spades cards are black, and diamonds and clubs are red. So that's for if you haven't played cards in a while. So the question, the first one is how many ways can a hand of 5 cards be dealt where all 5 cards are red? So we're trying to figure out how many different hands can there be where all 5 are red. So you really have to think about what is the number of items to choose from and how many times are you choosing. So even though there are 52 cards in a deck, we only want to choose from the red. So that means there are 26 red cards, the number of diamonds plus the number of hearts. How many times are we choosing? Well, we're getting 5 cards, so I'm choosing 5 times. So what we're trying to figure out is how many 5-card hands are possible where all the cards are red. Okay, so again, the reason why it's only 26 is because we're only thinking about red cards. And the reason why it's 5 is because we're choosing a 5-card hand. So, hand of cards, doesn't matter what card you get first or fifth, it's still in your hand. So this is a combination. So that's going to be 26C5. 26 factorial over 26 minus 5 factorial, 5 factorial. Simplify that. 26 factorial over 21 factorial, 5 factorial. These numbers aren't going to be as big, so it's going to be nice. So that means that 21 factorial goes away in our numerator. So that means we're only left with 26, 25, 24, 23, 22. And the bottom we have 5 factorial, which is 5, 4, 3, 2, 1. So, calculator. 26 times 25 times 24 times 23 times 22. Nice. 7, 8, 9, 3, 6, 0, 0 over 5 factorial, which is 120. So that's going to be 7,893,600 divided by 120 for an answer of, 65,780. So there are 65,780 different hands that you can have where all 5 cards are red. Pretty crazy. Now this video is running kind of long, so I'm going to do one more quick video for this last problem.